interface and transaction. And I've also shared that particular code. Let me share my screen. When you're developing SystemVerilog Testbench, definitely you need to have a very strong basics, like it may be inheritance or it may be OPS or it may be anything. Like about the mailbox or how you're going to create the mailbox and how you're going to pass the mailbox instances all and all, right? So those things are very, very important, and you need to have a good understanding of those particular things. Then only you can able to feel how the process is being happening, or else what is going to happen is, like, you are able to see the code, that's it. You cannot able to interpret what is going to happen. You cannot understand what is the process is being happening. Okay, so like if you feel like if you're not going to able to understand a particular point, let's say suppose I have declared mailbox handle over here and I'm copying it, but if you're not able to grasp it, like why I'm doing that particular thing, you stop there and try to analyze. You can also refer to the mailbox explanation videos which we have discussed it in very great detail. Okay, go there, refer there, and come back to this particular recording. Okay, so it will be like when you're attending any interview, it will be really helpful. Okay, so that's the reason. Okay, yeah, Ankit, then you can use AI for everything. Okay, so yeah. Okay, yeah. So coming back to our discussion, which we have started over here in the phase one, we are going to write the data, and then why we. But for attending interview, we cannot use AI and we cannot crack it, right? In your offline interview, if you want to crack an interview, you are not going to use AI, right? Can you please let me know how you are going to use AI for cracking your offline interview, so that I can also use that and I can also crack it? Yeah, we should see. Let's say, suppose if you're using a computer and you cannot complain that if I'm using a computer, then what is the use of doing the task manually and all, right? So AI is, use AI like your assistant. Okay, don't just rely entirely on AI. It's not a bad thing. It's a technology. Okay, so, like for example, if we are building a system Verilog test bench, instead of writing everything from the scratch, you are going to develop all the basic needs which are required, like for developing an interface class file, an interfacing generator file, and all. You can develop using AI, and you can develop what are the test cases or what are the extra test cases you need using on yourself. Okay, and you can also use it as your learning assistant. You don't care about whether people are using it in your in real industry, like people are using AI in industry. It's not like that. Now we need a job, so give me 1 second. People are losing jobs of AI. Okay, so you want to learn over here, or you want to do the argument with me? So, like, what is your purpose of joining in this meet? Can I know? Okay, it's not like asking, it's like you're arguing with me. Okay, it's not an issue. If you want to learn, you can stay and learn, or if you can leave. It's not an no one is forcing you to join over here. Okay, so let's start this particular session. So we have started with this particular generator where we have started with developing our phase one of writing the data, where we have used a for loop for writing the data, and we have created a transaction, and we have decided the operation to be a write operation, and we are also randomizing the things. Okay, and we are also checking whether the thing is randomizing or not using the if loop. Okay, and we are checking if this is not randomizing, then we are displaying that randomization is getting failed. Okay, and afterwards we are copying the particular data and putting that particular transaction, whatever we have randomized, we are putting it into the mailbox. Okay, and after driving driver getting that particular information, we are able to get the token from our driver using the get method. This is the phase one which we have developed so far. Now, coming to the other case using our generator, what we are going to develop is, let me write down over here. So let's see the phase number two. After this phase number one, we are going to develop the phase number two. Again, in this particular phase number two, I'm going to directly read from each and every address. So let's say this phase number two as direct reading from the address. Okay. Now, in this particular phase number two, I'm going to use for loop for int I is equal to 0, I less than number of writes. Okay. So I'm going to increment my variable I for that particular number of writes and I plus plus. Okay. And I'm going to create the instance txn is equal to new, and I'm going to keep my operation txn dot op is equal to read. And since it's a read operation, now here, to whichever the address which I'm going to write, from that address only I want to read the data. That is my requirement. To whichever address, let's say if I'm going to read to address number 2 or address number 3, I want to read from that particular address location. That is my main motive. Okay. So for that, what I'm going to do is, I'm first of all I'm going to collect that particular address which I have stored inside my array. So return underscore address of I. Within a for loop, I'm going to write, right? So from that particular array location, like whatever the address which I've stored inside my array, that I'm retrieving or fetching it, and I'm storing it in my address which is present inside my transaction class. Okay, and next, after getting that, I'm going to put it in my read mailbox dot put of tx. That's it. This is my phase number two. So after writing the addresses, I want to read from the same exact addresses. Okay. So that I'm going to give it to the read driver via the read mailbox handle. This is my phase number two. Now coming to my phase number three. So in my phase number one, I'm basically writing the data, and sequentially I'm going to read the data from the same addresses. Okay, by providing the same address to my read driver. So that read driver is going to provide the same address to my DUT so that I can able to read that particular data from my location. Is it clear, guys? Any doubts or any queries in this? Shall we move forward? Is it clear? Hello, am I audible? Yeah, Sai Kumar. Yeah, give me 1 second. Discussion. Okay. Yeah. Yeah. So coming to this particular code, that is what we have done. In the phase one, we have performed the write operation, and in the phase two, we want to perform the read operation by providing the same read addresses we have provided. Okay. Now, in the case of my phase three, in my phase three, I'm going to provide the random addresses. Okay, by providing the random read addresses to my read driver. Okay, so how I'm going to provide the random read addresses? So just I'm going to use a for loop for that. For int I is equal to 0, I less than number of reads, and I is equal to I plus plus. We are going to have, and we are going to create an object for this. And since I'm going to perform the read operation, I'm going to have txn.op is equal to read. Now here I'm going to randomize my address. Okay. uh, in the case of my phase two, I was having the what to say, the predefined write addresses, whatever the addresses which I was writing, those same addresses I was giving it to my read driver also, so that whatever the address which I was writing, from the same address I was trying to reading in my phase two. But in my phase three, I'm not going to do such. I'm going to provide the random addresses. So how I'm going to provide using the randomization? So if out of txn dot randomize, I'm going to check, and with an inline construct, op is equal to read. So here I'm basically randomizing my data, and after that, what I'm going to do, I'm going to check if this is randomizing or not. If it is not randomizing, then I can use a fatal command for stopping my generation, or else I can just display randomization failed. Display randomization failed. Now, after that, I can use a begin and loop. Yeah. Now, next, that's it. I'm just randomizing the things, and after that, I'm going to put the things into my mailbox. So, rd underscore mbox dot put of tx, and followed by end, and end task. So, this is how I'm going to perform the random data. I'm going to randomly read the data from my particular random addresses. Yes. Yeah, someone is having any query? Okay. Is it clear? Up to here, is there any query or any doubt? Okay. Yeah, never mind. Like people will be there, like they will be having some frustrations, and they will be showing it somewhere. It's not an issue. So like we know who is getting benefited and who is not getting. It's up to them. Okay, it's not an issue. Yeah, if you are having any query, please let me know. Yeah. So this is how we are going to have this particular generated class. We are basically having three phases where we are going to write the data. That particular data also we are randomizing, and whatever the data we are randomizing, we are basically storing into my what to say, inside my particular array. Okay, from that same array, I'm trying to read the data, so that whatever the data which I've written into particular address, from that data only, from that particular address only, I want to read the data. Okay, so in that phase two, I'm going to do that. And in phase three, I'm going to provide the random addresses so that I can perform random read operations. So there are total three phases inside my general. Yeah. Is it clear? Any doubts or any queries? Okay, great. Now let us see how to develop our driver. Okay, so let me share my screen. So coming to my write driver, after completing this generator, we are going to have the class which is known as driver. So I'm going to have class ram underscore write underscore driver. And in this driver, we are going to first of all have a interface handle declared with virtual keyword, virtual ram underscore interface dot write underscore drv. Okay, in our interface, we haven't declared any clocking block for now. Okay, so if we have declared any clocking block, we can use it, or else we can just declare the interface handle. For now, I'm not using any clocking block. Okay. Now, why are we using virtual keyword over here? Because class is dynamic in nature and interface is static in nature. Okay. So you cannot use static natured interface inside your class, which is dynamic in nature. That's the reason I'm going to use a keyword which is known as virtual. Okay. Now, after this, I'm going to have two mailbox handles declared. Mailbox, which should accept only the transaction handles. So the transaction class name is transaction only, and the mailbox handle is write underscore mbox. So this is mailbox handle which I've declared over here. And another mailbox handle for generating the acknowledgements or for sending the acknowledgements to my generator, which is known as write underscore done underscore mailbox. So these are the two mailbox handles I've declared over here. And another is txn underscore count, just for counting how many number of transactions I'm going to have. Now after that, I'm going to declare one function, and in this function, I'm going to have few arguments in this particular function. So one of the argument is of interface handle. Now, where are we going to create the interface instance? Where are we going to create the interface instance? Any idea, anyone? If we want to use the interface instance, where are we going to create the interface instance? So in my top model, I'm going to create the interface instance. So let me show you how we are going to create the interface instance. In our interface session, we have discussed this in clear, like how you're going to use your interface and how you're going to pass it and how you're going to use it. Okay. So if you want to use an interface, first of all, you need to create the interface instance. Okay. So this interface instance will be created in your top model. In your top model, you're going to create the interface instance. After creating the interface instance, this instance will be passed to your environment via the new method. Okay. And from the environment's new method, you're going to pass it to your uh, whatever the thing which needs interface is driver. So you're going to pass it to your driver. Okay. Like this, driver is going to get the interface instance from the top model. Why we are creating the interface instance in the top model? Because design also needs the interface. Okay. So design also needs the interface instance because all the particular design related things will be present inside your interface, right? So that's the reason I'm going to create the interface instance inside my top, so that in the top interface instance will be created. From that, it is going to be given to the test, and from the test we are going to give it to the environment. From environment we are going to give it to the driver. So this is how your driver is going to get the interface instance. Is it clear? Yes. Now after after driver getting this particular interface, so driver is going to have the interface instance. So what is driver going to do is it is also going to have the transaction class access. So transaction has some set of variables declared as rand, right? Okay. So that particular randomized variables will be taken by your driver and it will be given to your interface. So that from the interface, it will be given to your design. In the day one itself, we have discussed it, right? How your driver and design are going to communicate with each other. So whatever the randomized variables which are present inside your transaction, whatever the data which we have randomized and which are present inside your transaction, that will be taken by your driver, and driver it is going to give it to the interface, and from the interface we are going to give it to the DUT. This is how driver is going to drive the data to our design. Okay. Now let's see how to implement this particular thing. Let me so that's the reason my driver is going to have an argument, new function and an argument as interface. Okay. And apart from this, we are going to have the mailbox handles. Mailbox instance is also created inside your environment. Okay. Your environment is responsible for providing the instances of this mailbox. Okay. That's the new function we are going to have. And also mailbox hash bit right underscore done underscore mailbox. So these are the arguments which I'm going to have. And after your environment it is going to pass, we are going to copy it locally is equal to right underscore mailbox. This dot right underscore done underscore mailbox is equal to right underscore done underscore mailbox. And also the transaction count. Here, let me declare one more argument, which is transaction count. Let me declare it. Uh, can I declare or not? Okay, let's declare it. Int unsigned txn underscore count. Okay, so this we are going to copy it, txn underscore and followed by end function. So these arguments my environment should pass so that I'm going to copy it to my local copies. Okay. Now let me declare one more task, which is basically for purpose of resetting my design. So this particular task is reset, and I will. This task is going to have an argument which is known as cycles, like how many cycles you want to apply the reset signal. Let's have the default value of it as 4. You can give any particular value, not an issue. And let me display applying reset. Whoever is going to call this particular reset task, it is going to display applying reset task. And after this, I'm going to make all the particular signals to be 0. So I'm going to make my reset n equal to 0, which is active low reset. Okay. And if you carefully observe, I'm using the interface instance. VIF is my interface handle name. Where is my driver? Yeah, VIF dot reset underscore n. Okay. And also I'm going to give VIF dot write enable. I need to check what is the variable name which is present, which is declared inside your interface. WE. Okay, that's the reason I'm going to give WE is equal to 0. VIF dot W is equal to one tick binary 0. And here I'm going to give non-blocking assignment. And VIF dot address is equal to 0. And VIF dot W data is equal to 0. Okay. Now, after this, what I'm going to do, this will be repeated for whatever the cycles the user want, that number of cycles. And after that, I'm going to remove the reset. So reset underscore n is equal to one tick binary 1. And let me display reset d asserted and followed by end task. So this is the reset task which we have applied over here. So that I'm going to apply the reset to my design. That's it. Okay. Any doubts or any queries in this? I hope it is clear. Right? Any doubts or any queries? Yeah. Now, after this, let's declare one more task for driving purpose. I want to ultimately drive the data to my design, right? Okay. So for that, I'm going to declare a task which is known as drive, and it is going to expect an argument of transaction type. And let's say the argument is txn. So whoever is going to call this particular drive task, they need to pass the argument. Okay. And interface handle dot write enable. I'm going to make it to 1 because I want to perform a write operation over here. And address, I'm going to pass it VIF dot address is equal to whatever the address which was randomized and which was present inside my transaction handle, that I'm going to pass it to my interface. And who is going to give the TXN? TXN is being given by your generator. Okay, so this TXN handle will be given by your generator, that we are taking it, and from the TXN we are going to take the right address. We have just randomized the things, right? Okay, and next what we are going to do, VIF dot W data. So W data initially we will give zeros, a tick H 0. Okay. So this is what we have done over here. Okay, sorry. Let's give the randomized data which was present, W data. Okay. So whatever the randomized data which is present inside my transaction class, that I'm going to give it to my design via the interface. Okay. And after, let's say, some 10 nanosecond, or let's say some 20 nanoseconds. Let's say my clock time period is 10 nanoseconds, then I'm going to wait for 2 cycles, or let's say for 3 cycles we can wait. And after that, what I'm going to do is I'm going to deset everything. Right enable is equal to 0, and address is equal to 0, and data is equal to 0. This is what I've done. And following, I'm going to display everything, like what is your write enable value, what is your write address value. I'm commenting it. You can write the code over here. Display all the control, address, and data values. You can display them, and followed by end task and end class. Now, who is going to call this drive task? Okay, basically this drive task, is it clear? Just we are driving the things. That's it. Whatever the address, whatever the data, whatever the other control signals which we have got via the transaction class, that we are fetching it and we are going to give it to my interface. That's it. The driver is going to do. Where I'm using blocking, I'm using non-blocking, right? Everywhere. Nowhere I was using blocking. Yeah, non-blocking because you need to provide everything at the same time, right? You need to provide the right address, right enable, W data, everything you need to provide. The driver is going to provide them parallelly. Okay, the driving is going to happen parallelly. Okay, is it clear? Now, after that, we have one more task which is known as run task. This run task will be called by your environment. Let me write down over here so that when we are discussing about environment, it will be clear. This will be called by environment. Okay. And what are we going to do over here in the drive task? We are basically making my write enable to 1, and address is equal to whatever the address which we are going to have, that particular address. Sorry, I was talking about write task, right? Sorry, run task, right? In this particular run task, first of all, I'm going to create the transaction class handle, transaction txn, and also I'm going to create the object for it. No need to create any object because we are going to get it from the generator. Now, using a forever begin block for our begin, so the generator write mailbox handle is write underscore mailbox dot get of tx. After getting this particular transaction, we are going to call the drive task and we are going to pass the transaction. Okay. So after getting the transaction from my generator, and I'm going to give it to my drive task which is present, so that this drive task will now be able to getting, where is this drive task? Yeah, this will be called, and this will be getting the transaction class object, and we are going to fetch the data items from this transaction object and we are going to give it to my interface. Okay. And drive of txn we are calling, and after that we are also incrementing my transaction count so that I can have a track of it. And after the process has been completed, I'm going to put into my another mailbox handle, right underscore done underscore mailbox. Here we have declared right over here in my driver task. Yeah, this one, right underscore done underscore mailbox handle. We are going to put of 1 till my river. This will be given to my generator. In the generator, if you have remembered, this we were doing. Okay, that's it. This is what I'm going to do. Let me show it diagrammatically. So inside my driver, this is my design, and this is my driver. So driver is having interface instance, and also it is getting transaction object from your generator via the mailbox. So after getting this transaction is going to have the variables declared with rand keyword. All the particular randomized data will be present inside your txn. Entire txn object is being sent from your generator to your driver via the mailbox. Now, after getting this particular transaction object, This transaction object, using this handle, we are going to access address, we are going to access the control information, and we are also going to access the data. Okay, this particular information we are going to access, and we are going to give it to my design via the interface handle, interface dot address, interface dot write enable. This is what we are doing. That's it. This is the basic role of a write driver. Driver is basically driving the things. That's it. And this is especially write driver. That's the reason write enable is always one. In our code, we have simply given write enable is equal to one. We haven't randomized and we haven't given. Okay, that's it. Is it clear? Any doubts or any queries in this? One second. What happened to this? It has been stuck. Yeah. Generally, no. In your interviews, like what I've seen is they will be asking you how you're going to develop a driver logic. Can you explain the algorithm further? Like that snippets they are going to ask you, because writing entire TB code is not an easy task. Okay, and it's kind of time taking. Yeah, they might ask you like some. You can write down a snippet for explaining a monitor, or you can write down a snippet for explaining a driver. Like that, you can expect.